Okay. Okay, let's try it just from mic. So this girl is singing like this, yeah? So it's kind of crazy. And
So this was the overtone scale on one fundamental. I can also choose an overtone and move the fundamental.
yeah.
So I can choose a fundamental and have the overtone
So
scale.
she
or
she
I choose
sings,
an
and you can
overtone
see
and
on
have
this graph.
the
So
undertone
there's a
scale.
purple line always present,
If I
but
want to
different
sing
others are
special melody,
changing, and she's
and
doing
there
this
are
with her
melody notes that don't fit to
resonators.
the overtone scale from one fundamental, then I need to find another fundamental to sing this note. And for that, there are often different possibilities. The different possibilities of the overtone.
Oh, yeah.
Or I can move the fundamental in steps.
Yeah, so this is how you just. Oh my god.
Or in smaller steps.
Wow, she's doing crazy things about us. So.
Or even smaller.
She's almost playing chords, you know, so if we just go to synthesize this, so it looks like she's playing a whole chord with just her voice. So she's using different resonators to produce different notes at the same time. So it's kind of a cool use of voice. And when she just describes it, it's interesting. But you can analyze it and see it and maybe practice for some years to get at this level. It will be fine. So this was the only one request for us to check in this application, and now we're ready to dive into code. And my idea is just to show you how I do this thing. So maybe I won't cover even part of it, but you can proceed with me. So first thing, you can just go to GitHub page, and there's a Chromatone organization there, Chromatone. You can find it easily there, and then you can go to Chromatone Center repository. So there is where all the code is. So it's more than 1,000 commits. It's very nice repository with description, license, and all these folders that I use. And it has actions there. It has one issue open for a long time. Sorry. I believe it's about some very niche thing about coloring notes in ABCJS. So it will take some time to implement. So how I do it, I just open my VS Code, and I believe most of us who uses VS Code also. Can you raise your hands? So not too many, but I don't know which which code base you use, but a code editor you use. But I think it will be just similar result. Then I love to use this extension called actions. How it's called? 1 minute. Actions. VS Code action. VS Code action button. So I just need to press this button in the low. So dev, and it starts development server. If you don't have this number, this button, you can type pnpm run dev. But of course, if you fork the repository, you will have to install. So pnpm I, you will install the dependencies, and pnpm run dev, and you will have this development server. Then we have this server running, and then so this website is locally hosted, and we have the pleasure of hot module replacement, so we can just edit any information on this site. And let me show you the code structure a bit, so you can be more familiar. So there is this audio folder. There is all the audio engine stuff, but for new audio engine that is still in development, and I will show you. This is another request for today. Also, there is components, and there's plenty of them actually. So each folder has some components, and each folder is a feature or an application mostly in the practice session. So, and they're kind of self-contained, so you don't need anything from outside. So if you have, like, for example, GPU, I have this GLSL shader, and you can look at it if you type in the search GPU. So if I play like a chord, it's very robust. It's hardware accelerated, so you can get quite fun with this. So let me get to Chrome, because if you want MIDI support, there are problems with Firefox sometimes. So it's kind of introduced the API, but it sometimes just stops working. So Chrome is more stable with that. So then I just turn on my synthesizer, and it's playing some music. And this analyzer just shows you the notes, and you can filter out the incoming channels. So if I turn off all the channels, nothing's coming through. But if I turn on different channels from a synthesizer, it starts showing them. So this is quite versatile, and you can see that my synthesizer is connected, and you can see that there's MIDI out, so I can control my synthesizer from the website. And also there's clock out, so the website can control your synthesizer and make it run in sync. So if we, for example, go to practice circular rhythm, circular metronome, and then I just press play, immediately my synthesizer is playing in sync. So if I play stop, it stops. So yeah, MIDI is there. And this button enables you to have MIDI synth, so the computer will produce sounds. Yeah, so you can see this GPU has this code. Is it visible? I should make it a bit bigger, yeah. Like this, probably. So I just get this example, but it's just self-contained. So I just import this GLSL code that I wrote with ChatGPT, actually, because I'm not deep into this WebGL, but it really helps to write unknown languages, and I hope you enjoy it too. It was like back and forth. I was telling it to write me some code, then I tried it, it didn't work. I get back why it's not working, so let's solve these problems, and finally we get it. So I import Vue. So this is a reactive system behind this. So I prefer this reactivity concepts, and it's very robust now with Vue 3. Then the Vue use is this library that has all these important parts. So like use Vue window size. So it's just reactive window size. So you don't need to have event listeners and check for this periodically. You just have this reactive value and can react to it and watch it and do things with that. Also, there's use transition that can smooth out any changes in your visual thing or code or UI. Also, there is more precise reactivity system tools. I also import things from the use folder that is like the common thing that is used by different components from the website, and also that is exported as a use Chromatone package on npm. So if we have these components, then there's content, and this use folder has all these TypeScript files that, for example, show us this MIDI. So again, use storage. I just have local storage reactively in my hands, so I just can write into it. Use clamp, so I have minimum, maximum values, and the reactive value will never go out, so it's very useful. Reactive, computed, watch effect, all this is used, so yeah, many things to import. Again, web MIDI, gives us the interface to interact with your MIDI synthesizer, MIDI device. Also, this keyboard is how we play keyboard on the computer and produce sounds. And also, the tonal library gives us some music theory basics. So, chord and MIDI are the things that help us kind of guess chords from notes that are incoming. This is standing behind this main screen, because you know, if you just open the website, it immediately shows you the notes, but it shows you the chords also. So you can just look at it and meditate again on it. And one thing. Once I met my friend. He's a musician, and he told me that he hates Chromatone really because he has different colors in his head, and this was the problem. He has synesthesia, but from birth. So he was not comfortable, and just for him, I created this thing, so you can just go and adjust it to any color you want, and it will work basically in most. I think most tools will work with these colors. Yeah, A is green here, again. But yeah, then I hated it too, because I get lost very fast. So you can just hit this button and get back to original colors. But if you have colors in your head, if the tints and hues are different, you can always adjust Chromatone to you. So it's more visual, not just colorful. Yeah, I'm a bit chaotic. Are you okay with this? But I want to show many things, and I of course won't show everything. But yeah, I just want to show you the idea how I do this. So, yeah, I don't like TypeScript really. I don't like writing it and debugging these types, but as an author of this use Chromatone library on the npm, I'm obliged to have types for users to have pleasure, to just import an interface and have this autocomplete there, so it's there. Again, you import only one thing. You import only these reactive objects, just MIDI object. And it's reactive. It will show you if it's enabled, if it's initiated, if it's playing or stopped, what are the inputs, what are the outputs, what channels do we listen to, what do we ignore, the last and recent note and its pitch, integer based, so 0 is A and until 11, that is G sharp, on which channel and which velocity is there. Of course, we can control if we on and off the keyboard on the computer, the control messages, and yeah, this auxiliary objects like this active notes. So it will show you only active notes that are present, and guess chords will show you a list of chords that the program is guessing. So just this one object is very, very powerful, and I made it quite fast, and these computed properties are optimized pretty well, because Vue 3 is very optimized and they use very robust APIs of the browser, so it's fast and doesn't load your system much. Except one thing, that if we have so many things in one library, the whole library is more than a megabyte size, and I'm thinking about maybe separating it into separate packages in the future, so it will be lighter for you to import. But yeah, there are functions to play notes, and when we play a note, it's just when we get a note from a MIDI interface, we process it and throw it into MIDI object, and vice versa. So the paradigm is you can import this just simple object, but the best way is to use this useMidi. So we have the space to initiate. So we have the space to initiate the state, so we can set up the keyboard, so the keys produce MIDI messages too as a keyboard on your MIDI. And we can watch for the outputs and inputs. So if I just plug in and out my device, you can see it appearing back. Yes, so you don't need to reload the website to have your MIDI connections established. Yeah, so how many of you are following with your computers? Because we can just start creating something together. Because what do I do next? So we have these use functions that are pieces that we can use, but they're not visual, they're not UI, they're just data. So I would go to content. Content is the main content folder. Here are the all the folders and all the files are analyzed by Vitepress, and all the markdown files become HTML pages for the website. So if you want to create a new page, you will just create a markdown file that will have a little description. So it will have a title, description, and some parameters that you can use. But here we can see just the main page, and this interactive flower is Chroma flower component, and it's auto-imported from the component folders. Components folder from here, Chroma flower. Yeah, here it is. So it's imported from here. So you can just mix and match different components in a page. So I would go to practice and experiments, and there's plenty of them. And I can create a new folder like coding colorful sound, like CCS. Okay, it will be. I have only one hand to type. It's not very convenient, but okay. That will be like index markdown file. I will have a title here. Title. I'm sorry for typing with my hand. So CCS again, and that's enough for now. And here it will be like hello. So just having this created this file there, I can go to practice, experiments, yeah, and I would refresh the server. I think it will be there. Because yeah, if you create new files, it's not every time. Yeah, CCS. So here we have this hello, just there. So this code is quite interactive. So once I save it, it's immediately shown. So it's very fast to experiment. And we can just start experimenting right there. So if I put a script setup here and import MIDI from MIDI, use just from use, it's enough. Use is enough. So if I put this MIDI object here and save it, no, use like this. So there's no, yeah. So here's the MIDI object reactive, and we can just play with it. So you can see that there's OPZ connected, the manufacturer of it. You can see the clock. So this will show me active notes. So it shows a MIDI number and a velocity. So you can just react to it. You can show the color. You can show the, I don't know, height of a bar if it's velocity. If you have velocity sensitive instrument, you can react to velocity. If it's not, you can just react to notes. And the formula for the color is very simple. So if I, for example, take the note object, MIDI note, so it shows us this timestamp channel, yeah, and velocity, number, pitch, and octave A. Octave A is octave, but regular octave count from C, and we count from A here. So if I want to get a color for this note, for current note, so I can watch MIDI note pitch like this. So it just shows me the recent pitch of a note. And to get the color of it, we just need to multiply basically this by 30. And this will give us the hue angle, the hue of a color. So the only thing we need is to MIDI color. So we just get the note and feed it to pitch color. And what is pitch color is this function. So basically it gets a pitch from 0 to 11, an octave, so we can get lighter and darker colors. And yeah, this is the code. So HSLA, then pitch by like modulo 12 gives us ability to have any high numbers of pitch, but it will be folded down to 12. Then velocity determines our saturation, and lightness is dependent on the octave, and some little adjustments to make it nice to look at. And alpha. So this is the core function in the whole system. Except when we use these adjustable colors. But yeah, so I can show you all the colors available just here with one moment. Pitch. Where's that? Sound. Table. It's table, definitely table. Pitch table, yeah. So these are the colors, and I want you just comprehend this. So you bring up. You just with touch, you can use multi-touch on your iPad or any any device basically, and you can just bring any note that is available. And it's kind of weird instrument to play, but yeah, if you touch, it turns off, so you can bring sounds and bring them down, and you can choose different scales, so you can still play these dark notes, but if you prefer to choose like A major, so stay with these notes. But one important thing is the colors. So how are the colors? If we go higher, the colors get lighter and lighter. So this color, we can even check your age, and because this sound everyone will hear. You hear that? But it's kind of faint. But this, no one here. But I think there is a problem with our reproduction system. Yeah, it's not doing well with high frequencies. But I mean, you can check with your headphones, and you can check which is the higher note you can hear, and this determines your age, and maybe you can turn down the volume in your when you're listening to music and have your hearing for longer. But this is like octave 8, this higher. We don't need to get over this because 20 kilohertz, no one will ever hear that except maybe your dog. They can hear even higher. But the wonderful thing happens when we go down there. So we can go like this is a note, yeah. This is a lower note. So we're going into this dark territory. Are you ready? So this is still a note. This can be played on a trombone. I don't know, some maybe organs can play this. But we're developers. We can go deeper. And so D-2. Can you guess how does it sound? Yeah, it sounds horrible. And it's in the middle. So if you get into the research, we have two ways to perceive oscillations with audio. If they're high enough, we perceive them as notes. But if they're not high enough, if they're low, we perceive them as rhythm. So this is still D, the note D, but it's minus third octave, and it's how much? 550 BPM. Still very fast, but this is already a musical rhythm, and internally it's still oscillator, sawtooth oscillator, getting its work. But imagine, so if we are into this sound territory back, so imagine if we have like this A and this E, this fifth interval, so it's very pleasant, but this is very unpleasant, yeah? So with rhythms, it's kind of similar, so if we... It's kind of nice, yeah. And it's periodic. We can find this period is quite short, but if we go with the close rhythm, they diverge and converge, and there's a beating, and it's not that pleasant. And we can just use this as consonances and dissonances, but in rhythm, so it's very useful. And one main implication from this is that rhythms also have colors. So like if you get regular 120 BPM, like house music rhythm, it's C. And you can use it if you're not easy to choose a scale, which one you want to use. You can start tapping, and then you can, for example, go to rhythm circular metronome and start pressing this tap tempo. So this is my internal rhythm, yeah, but I've tuned to 120, but I can like this. So around 100, okay? So this means that I can go back to this table, and so it's B. So rhythm in B, and I can start playing B, note B, and like this, so. And if I have a B, I can play F sharp. Yeah, so it's music basically, guys. Then you can just explore these possibilities. But I mean, I think dubstep was invented something like this. Yeah, so I just found out that I cannot code much by one hand, but I can show you more examples of it. So everything starts with this experiments folder. I bring any new library from NPM and grab it and start exploring this. And there are many experimental and not finished projects there. So, but after I'm comfortable with them, I kind of publish them, just dragging them into neighboring folders. And there are quite esoteric ones. This one is not optimized at all. It's very slow, but yeah, it's like, yeah. So we have this noise and the circles, and the parameters. The circle grabs the color. So each circle scans and finds the color, and if it's dark, it's low value. If it's light, it's high value. And then these values transfer to different parameters of our sound synthesis. So you can manipulate it in many ways. You can drag it somehow. Yeah, you can zoom in and out this noise and limit the fluctuations of the parameters, and so you can create pretty interesting landscapes with this generative interface. But yeah, it doesn't look consumer friendly yet. But that's how it moves. And one request that we had from the audience is to show you this elementary audio engine that that I'm kind of using now and that I'm experimenting. It just recently moved out of the experiments to the synthesis folder. So there is a plenty of different synthesizers that I use there. So Chuck is one of them. You can just type program very weird stuff there, and you can. So basically, it's this code that can be run by a virtual machine that will create kind of musical stuff, but it's not very stable, and it's hard to control, so I abandoned this experiment, but you can still get inspiration from that. Also, synth is kind of same thing, so I imported this library and used it for exploring this synthesis there. So it's just this component that can be found in the component folders. So synth, yes, this, and there is this, yeah, Amy synth, and it has very esoteric also code to play. So they can show you, yeah, these sounds. I don't know, but there's so much debugging about this. How it's called? I mean, it's kind of weird to control. It gets out of control. It gets lose control of it. But this elementary synth is kind of different because I really enjoy working with it. It's kind of new tech. Previously, it was closed source. It was proprietary, but the author recently made it open source and was very nice to talk about. He's very responsive in Discord. And with this, you can have very, very high quality and high control about your sound. So, of course, we have this spectrogram there, and also this waveform and the volume. And I made this consist of two parts. So there's an oscillator that's making harmonic part, and I can turn it down, and too much zoom. Okay, and also there is a noise part there, but it has a filter, so it has at least a little bit of note to it, and you can control attack, decay, sustain, release, and also these effects. So and together they get very pleasant sound actually. And more release. This can be less release. Attack, like this. Yeah, and you can control it, but these are just basic controls, and it's never enough if you start composing your sounds and creating your music. And I'm thinking how to make this a very interactive, like with UI, but the fun thing is that you can actually write your own synthesizer that way. So let's look at it in internally. So synth elementary also is just importing this audio, LM audio. So audio, LM audio, yeah. So this is how it looks. This main component imports subcomponents that interact with each other because they all share this use audio file, and they all import the same file. So it can be initiated, and there's a core, there are layers that we control, and there are also these scopes and meters and FFTs, so we can grab the information from the audio like flow and control this flow in any point. So this was my big win, and I want to share this. So this is how you make basically metronome and the whole transport from scratch. So here it is. You can see it in time. LM use time. Yes, here it is. So this is one moment. Yeah. So elementary is a very interesting technology because behind the scenes it's WASM based, very efficient code that's running underneath, but on top you have JavaScript interfaces, so you can control it with JavaScript, and it gets real power in your hands. So we start from just having this elementary time, for example, and wrap it in a meter that's just elementary meter basically. So we have this time here. So this is just the number of not seconds, but samples. So there's 44,000 of them each second, and this is always growing constantly. And we can get this sample rate, but elementary SR, and this is sample rate. This meter is shown there. Okay, I will show it like this. Then we go to pitch, because I like to calculate pitch for the tempo. So this tempo has a pitch of this, but if you get the color of it, it will be good color. So it will be green for now, as we have this BPM. And when we change BPM, the color changes. So we immediately get this color. And yeah, if I just hit play, so this is already running. So we are using this information from just time and sample rate, and then we start calculating all the steps and when we want the sounds to play. And let me guide you through this, so I can share this revelation for me, and maybe you can use it in your projects. So next, what we do, we just divide the time by sample rate, and we get seconds, because it's just per second, samples per seconds, and yeah, we get seconds. So we can see it somewhere here. Yes, 300 seconds are run already. So then we have this start, that is just the value of our transport control system, so we can say it, you're started or you're paused. This is just Boolean. This is a function, so it's greater. So if it's greater than 0, so if it's started is greater than 0, so we get this is started, and it's here. So when I press play, we see this as 1. When I press stop, we see this as 0, and we get these flags that are useful for our transport control, because we don't need we need an ability to start and stop, despite the time is always growing in this system. So we have this select function that can, yeah, but we need to go from the very beginning. So sub is subtraction, so seconds are, so we have seconds and we have a time when we started. So we get the time where we are now. Yeah, this is quite complex. I spent hours debugging this and finding how it would work. So you just can copy and paste it. Yeah, but it gives you current time and where is it? Current. Yeah, here it is. So this means that you have this seconds, but already relative to your transport. So I can pause it and it's still 5 seconds. I can stop it and then it's 0 and run it back again. So this is how it works. And I also can have more steps. And yeah, so this is already all you need to build a sequencer, maybe control not only audio but MIDI, because you have these meters out, so you can throw these messages to your MIDI device through the MIDI object and control it. So I have this BPM control here, so yeah, this just works. And the reactivity is working very nice with this elementary functional programming, because I've constructed this CV function. It's similar to how synthesizers, modular synthesizers work. So I can just have this this use UI helps me a lot. This is very, very useful thing that I use. So I can have reactive objects that control the functional part of the elementary. Yeah, so then this is the musical part. So at this point we have just seconds, but we don't play seconds, we play beats. And so we need to divide our, so we have BPM, then we divide BPM by 60, we get BPS, beats per second, because seconds are our minimal measures. Then we divide our seconds by BPS, so we get beats, how many beats elapsed. So we can adjust, we should know the number of steps that we want. So if I want 12 steps, it will be 12. And then we will divide the number of beats by the number of steps we have in a measure. So we get the measure, and the measure is the real musical thing. You can play your chords in a measure, or melodies are defined by how many measures it continues. So this is we're getting into musical territory already. And then we need this beat and pulse and step and all these kind of flags, so we can react to them, because pulse is a thing. So if beat is just a modular of beats by 1, so it will be just 1 0 1 0 1 0. Yeah, so if it's over 0, we will have a pulse. So pulse will show us that it's time to hit something. So here's the pulse. Yeah, tan 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 tan. It's just showing this 1 1 1 1 1, and then this pulse is going into this head synthesizer. Yeah, so it's a very modular thing to explore. So with elementary, you can just have parts of a code in a separate function, and this head synth is using noise and is using some maths and using a bandpass filter and ADSR into it, and then we can just use this to create this sound. So this sound is also created inside elementary. So we have this immense control over this building blocks. They're pretty low level, and even for me it's quite hard to navigate this time dimension kind of. It's very hard to get there. But once we're there, we can just build on top of it. And this is the pleasure to share it, these bits of code. And I've shared it in Discord of Elementary Audio, and they all love it. And they want me to make it in a separate library for everyone to use. But yeah, it's a it's a thing to build yet. And if you will get into it, I will be very happy if you can contribute to making this a separate library. Yeah, so just to wrap it up. Yeah, so here is the whole. Yeah, so it's just basically working. So it's just another layer, but all this is just made without any samples, without any kind of pre-built systems. It's just built with basics of noise and maths and trigonometry, and this produces sound. It's a pleasure. And I want to share the bits and, of the repository. So one thing is that there are like information about music that can be also used in explorations. For example, this guitar file contains all the chords, just all the possible chords with fingers, numbers of fingers, and frets where they are positioned, and also the MIDI notes that are at these positions, so we can use it to create very easy to navigate toolbox for guitarists, for example, like this. So we can have chords and all the chords in a given scale. So it even has all the inversions, and you can go and choose which chords you want to play. And yeah, it's kind of nice to have this exploratory tool, because you can just yeah, it's easy to start with basic chords, basic scales, but there's that many of them. So you can choose like very esoteric Lydian sharp 9 scale, F sharp as a tonic tonic note, and then there's not many chords there, but still you can manage to play F sharp major, this, and on ukulele, on your guitar also. And this shows which notes are in the scale and in the selected chord. Yeah, and it's basically combining all these pieces. So the database gives us the numbers. The use folder gives us the ability to get the colors. It's basically SVG, so we don't need a library to write these graphics. It's just circle and line and text nodes, and we react and we create like reactive objects. So we react to this global scale object that gives us the scale and notes. We react to this object that defines which instrument do we use. And yeah, it's just, when I see these possibilities, I try to explore them as much as I can. Then I find myself playing music, debugging things, playing music, debugging things, and yeah, it's a fun way to have time. So maybe you will find yourself in a similar loop sometime. Yeah, and one thing about these chords, I think this tool, if you want to learn music and create music, this will be your go-to, the main tool I think that you will use, because this defines the harmony of a song. This defines which chords go well together, and you can just experiment with it, because you choose tonic chord, so you can go around and find the combinations of chords that you really like. Then you can go to this guitar fretboard and find how are they constructed, play them. And also there are seventh notes, more fancy jazzy sounds, and also inversions. These are the same. This is D chord, but different inversions based on different notes and different combinations of them. So I cannot cover all the possibilities of this system and of all this build setup, but I hope I could show you this like space of possibilities, because my idea is that Chromatone is enabling people from all over the world, because it's international. It's enabling people who could never learn music without it, because it's too hard to learn music as regular students. And now we can find ourselves in a territory where we get new people into development, new people into music, and then they collaborate and then create something very different, very new. And it's something that I'm not sure how it's shaped, and I don't want to dictate this shape. I think it will evolve with time and with communities and how they think about it. But I think it's something about just casual music playing together, maybe bi-weekly, maybe monthly, people getting together, putting up these visual tools and having like playing music with complete strangers. This is my idea. So you can, it's easy to play with the band with which you play for a long time, but with strangers is always frustrating because you need time to get in sync. But with these tools, you can get in sync with strangers, and when you're in sync, you get the connection. You feel like you're in I don't know, a friend or a family, something like this, because music is what connects people. And so we can find ourselves in a new territory where we live in a more interconnected communities, where we can never talk to someone but feel the connection because we play music together from time to time. And it's not because we're professional musicians, but we know how to just start and do our thing. Because if you see, like I'm playing like this on my synthesizer, or like this here. So even you don't hear me playing, you can understand. Oh, I know it's G, it's E. So if you know G and E on your instrument, you can just play this E and G and just be in harmony. But then you can think, oh, E. So A is fine with E because it's a fourth, so I will play E. Or B. B is fine with E because it's fifth. So we can start thinking as musicians, but not paying this pain and time, like years of practice. We can just go with it like in months, not years. Yeah, so I think I've covered most things, but from high bird's eye view. There's a theme folder for the whole website, so the navigation and the all the global things that happen here, because we have controls over the rhythm, we have controls over MIDI, we have controls over synthesis a little bit. So if I turn on MIDI synth, go here, you can hear square wave, triangle wave, sine wave, and volume. And also there's crazy things like recording audio, recording screen. We can even start our like this just on the website. So if you want to share some music knowledge, you can just turn on your camera and then turn start recording your screen and also record your audio, show some things there, play music, explain things, and then just stop this, and you get the files there. Like
Start
this.
recording your screen and
Yeah, so one file and the other file is the audio. Yeah, the third file is there. So screen recording is fine. Yeah. So this is the toolbox for everyone to play with, and yeah, if you have any questions, you can ask them, and I will answer them. Yeah, I think that's all for now.
Please
Please.
give us feedback because this event is like we are kind of experimenting. We are keeping experimenting with different event format, as if you have an idea you want to run a creative coding meetup event. Yeah, help us continue this series. You can let us know. Maybe me, Poom, or Pap. Yeah, yeah, or contact Creators Garden Facebook page. Yeah, or like just let's talk. And um, finally, I want to thank you, like Pat, for doing the MC thing. This is all very much improvised, and I want to thank you, T, for helping manage the live stream and stuff, and also this slide. Angli also, yeah, Angli designed it. So thank you. Yeah. So
Oh,
everything
well,
happened like in a few hours. Yeah.
yep.
Thank you.
So you guys are welcome to watch the live video. It will also be uploaded on YouTube. So if anybody missed any part, it will be available there sooner or later. I have no clue. We'll know. And yeah, hoping that's all. That's all.
Yeah. And thank you for coming, everyone.
Yeah. Thank you for coming. Have a great night.